Okay, so our goal in this problem is to find a region whose area is equal to the given limit. So we're supposed to find some sort of function, and it could look like, you could graph it and whatever. It looks like this, but the function has an area that's in here that is the area under the curve is represented by this limit right here. So that's the goal. So the answer that we're looking for is going to be just like f of x equals stuff. We get some sort of function, right? And then you're going to have a domain from A to B, where this is your A and this is your B. Okay, and what I know is this formula right here can be rewritten into more of a generic formula, which looks like this. The limit as n approaches infinity of the sum of I, starting I equals 1, to n subintervals of f of x sub I delta x. Let me just make sure not that it matters, but let me make sure this is not backwards. Make sure it's just like the textbook. And we're good. All right. And what this is right here, like this little piece right here, represents the area of a rectangle, where this right here is the width. This right here is the height. Okay, so you get the height, you get the width. You got a rectangle. Bam. There's your width. There's your height. There's your delta x. There's your fxi. And what the xi means, I'm going to emphasize that y right there, is that when it's all said and done, you're not going to be plugging in any x value. You're going to be plugging in a special x value. So this is more like f of special x value. Okay, and if you think of this drawing right here, you're going to make, the whole idea about this is you're going to have a bunch of little rectangles, right? And I'll draw them like this. Yeah, that's a good way to draw them. You have a bunch of rectangles like this. Okay, and right here is, I'm going to move this A to the side a little bit. All right, so right here is delta x. That does not look like a delta x. Right here is delta x, which is the width of the rectangle, right? And then the height, it's kind of a lousy drawing. Let me just do it like this. The height, let's say, is right here. If you're doing like a right side height, because you could do the height from the middle of the rectangle, you could do the height from the left of the rectangle, but we're going to do it from the right here. And so we'll draw a rectangle like that. So where the right side of the rectangle, you're going to go up on that base where it connects with the curve. You go to the right here, and that is f of x1. So then this right here, this height right here, or that location, is x1. If you say it generically, you're going to say xi. Specifically, that's x1, and over here would be x2. So it's all your right sides of your rectangles. Okay, so this right here is not any x value, it's a special x value. And in our case right now, it's going to be the right side of your rectangle. So right here, I'm going to write special x value. Better yet, I'm going to call it a smart x value. That sounds even better. A smart x value. That kind of implies that it's like not random, it's by design. That word is smart, believe it or not. All right, so notice how you have a function right here, right? It's a function times delta x. And here is something that looks a lot like a function, right? This right here looks a lot like a function times something. All right, so that means that this something right here is delta x. All right, so that's your delta x right there. Okay, so we can say that delta x equals 3 over n. Okay. Oh, and this I, that I has to do with your smart x value, right? So if you want to know the area, so if you want to know the area of, like, let's say this rectangle right here, would that be I1, I mean x sub 1, x sub 2, x sub 3. So then your I would be 3. You plug 3 into your formula, you're going to get, you have the width right here, this gives you the height, and bam, or there's your height, but you're going to get the area of the rectangle. And n just means that's like how many rectangles you have. Okay. So we have our delta x. Delta x is equal to 3 over n. We're also going to use the formula that xi, the smart numbers that we're picking, is equal to a plus delta x. Okay, so xi is equal to a, and that just means that you're going to start with your a value, which is right here, and you're going to move over delta x to get that right side of the rectangle. So this is kind of the right side of the rectangle smart value. Right side of rectangle smart value. Okay. Well, we know what A is. We know that A from, wait, do we know what A is? Hold on 1 second. We do know what A is because I forgot to mention that, or I probably did mention it, I don't remember, that inside like your function, you're going to have delta x somewhere in there. So this value that's right here, it's going to be hidden in here. And there it is. I'll make it the same color actually. Right there. Right? So there's your delta x. Oh, hold on 1 second. Oh wait, you know what? And right here you're supposed to have an I. Right here. Right? So if you wanted the first like smart value, well that would be a 1. and then you'd have that a value of whatever it was, and then it'd be plus your delta x times 1. All right, so it'd be this a plus delta x, bam, there's your first smart value. You put a 2 right here, you put a 2 right here, or times 2, right? And then all of a sudden, you're going to go here, plus delta x, plus another delta x, and then bam, you got that value. All right, so you got to have your, let's see if I can go, yeah, you got to have your I right there. All right, so here's your delta x, or your delta xi. Okay, so if that's your delta xi, then that means that this guy is a. And you kind of know that because we're dealing with a function, f of x. So let's say our function is the square root of x. Okay, so if f of x is the square root of x, then that means that whatever you put in here needs to be whatever goes in there. All right, so let me just spread this out a little bit. Wait, so I'm going to do f of, I didn't really have to spread that out. If I'm going to do f of xi, well, that means it's going to be that, because that's what xi is. All right, so go over here, and that's going to be a plus delta xi. Okay, well then, well, what's delta x? Delta x is 3 over n. All right, so let's just down here, let's say that f of x of I equals the square root of a plus, or delta, which is 3 over n. So you have your 3 over n xi. Okay, well that looks a lot like this right there. Not quite, but if I say a is 1, it does. Right, so then we're going to say a is equal to 1. A is equal to 1. If a is equal to 1, then I can say that f of xi is equal to the square root of 1 plus 3 over n xi. All right. Well, that means that my original function, the one from the very beginning that I thought I wrote down, I must have erased it, was f of x equals the square root of x. That's the original function. This is the input, right? So that means that I could do this a better way. I could say that xi, that xi equals a, which is 1, plus delta xi, and delta x is 3 over n, 3 over n, I. And that's your a. Okay? Well, there's another formula, I guess I didn't mention it, that I'll do it over here, that says delta x is equal to b minus a over n. Okay, so delta x, that's this width right here, is equal to your high number minus your low number divided by however many intervals you have. Okay, so real quick, let me just kind of show you. Let's say I have something like this. I'll just draw it like that. And I'll go, oops. 1, 2, 3, 4. Okay, so I'll go like that. That's supposed to be a perfect rectangle right there. All right, let's say that's 1, and let's say that's 3. Okay, so delta x is equal to your high number, which is your 3, minus your low number, which is your 1, over n subintervals. And in this case, I have 1, 2, 3, 4 intervals, or subintervals, I guess. And then 3 minus 1 is 2, is 2 over 4, which is equal to 1/2. That means that the width of each one of these guys is 1/2, right? So 1 plus 1/2 is 1.5, and 1.5 plus 1/2 is 2, and 2 plus 1/2 is 2.5, and 2.5 plus 1/2 is 3. See, so that's how you get your delta x. All right, so we can use this formula right here to get our b down below. So we know that delta x is equal to b minus a over n. But we also know that a is equal to 1. So we know that delta x is equal to, I'll do below it. So we know that delta x is equal to, b minus a, which is 1 over n. But we know what delta x is. Delta x is 3 over n. All right, so we can substitute that in right there and get 3 over n equals b minus 1 over n. All right, multiply both sides by n. N's go away. Okay, then you're going to get 3 equals b minus 1 plus 1 plus 1. B equals 4. Or I hit it like that. B equals 4. Okay. That means that our domain is from 1, that's our A right here, to 4, right there. Okay. So we pretty much have it. So we have our so A equals 1, and where should I get that? It's right there. That's ugly. Hold on a second. All right. I'll go down below like this. Right there. So B is equal to 4, and A is equal to 1. Therefore, we're going from 1 to 4. All right. And we have our equation. Our equation is f of x, right here, equals the square root of x. So you just want your most basic equation, f of x equals the square root of x. And the interval is from 1 to 4. So if you graph that, you go like that, you go like that, and you go from 1 to 4. The area under this curve right here is represented by this limit right here. The one above it, actually, by the one right here. Which means that if you were to take the integral from 1 to 4 of the square root of x, you would get the area under the curve just like you would get the area under the curve with all this limit stuff right here. It'd be the same answer. So this is the area under the curve from 3 to 4, except 3 to 4, not 3, why am I saying 3 to 4? From 1 to 4. So, so the 1 to 4 business is basically hidden in here. So it's hidden in this sigma notation. And the actual function itself is kind of also in disguise in there as well. It's kind of right here, it's right here, but it's in disguise. All right, so, but the actual answer to this problem is right here.